April 8th, 1943, 27,000 feet above Conches, France. The air was thin, clear, merciless. From the cockpit of his Focke-Wulf 190 amperes 5, Oberleutnant Ralph Hermacham squinted through the crystalline canopy at a cluster of massive aircraft clawing their way up from below. He grinned behind his oxygen mask. "The Americans have sent us flying milk bottles," he transmitted, and laughter crackled across the radio channel of Jagdgeschwader 26. Below, 16 Republic P-47 Thunderbolts of the 4th Fighter Group climbed in formation, slow, heavy, their 2,000 horsepower Pratt and Whitney engines groaning under 7 tons of steel and fuel. To men like Hermacham veterans who had fought over Britain, France and Russia, these newcomers were absurd. The German sky was ruled by machines of grace, Spitfires, Messerschmitts, and the sleek Focke-Wulfs that danced like blades. But the Americans, they had built something grotesque, a barrel-shaped fuselage, wings that looked too short, a propeller so large it seemed to mock aerodynamics itself. The Thunderbolt looked like an accident with wings. Hermacham tilted his aircraft toward the sun, preparing to dive. He could almost pity the poor souls inside those lumbering beasts. But what he didn't know, what no one in his squadron knew, was that below him climbed the future. Each of those milk bottles carried 8 Browning, 50 caliber machine guns, a rate of fire that could tear a fighter in half in under 2 seconds. Each was powered by an engine that could breathe freely where German machines gasped for air. And each was built on an assembly line that could produce one every hour. In that thin blue silence above France, the Luftwaffe's finest were laughing at the embodiment of their own defeat. The war had already moved beyond men. It belonged to the machine and to the civilization that built it. To the German High Command, air superiority wasn't just a tactic, it was an article of faith. They believed that wars were decided by speed, precision, and the will of the pilot. The Luftwaffe was an aristocracy of the sky, built on reflex, discipline, and mechanical perfection. By 1943, that faith had been justified 100 times over. From the blitzkrieg across Poland and France to the duels over the English Channel, Germany's pilots had proven themselves unmatched. Their aircraft, the Messerschmitt Bf 109 and Focke-Wulf 190, were masterpieces of engineering minimalism, light, agile, lethal. The doctrine was simple: climb fast, strike fast, vanish. Each pilot carried the war in his hands, his skill, his instincts, his machine. To the men of the Luftwaffe, the American P-47 Thunderbolt was an insult to that philosophy. It was everything they weren't: heavy, slow, and above all, inelegant. The German logic was built on efficiency, the purity of motion, and the economy of mass. Yet that same logic carried a hidden flaw. Germany's aerial empire rested on individual excellence, on aces who could not be replaced. Every kill was personal, every loss irreplaceable. The Americans saw the sky differently. To them, air power was not an art. It was an industry. While the Luftwaffe revered the pilot, the United States worshipped the system. In factories across America, men and women who had never seen Europe were building war machines by the thousands. Republic Aviation didn't design aircraft to win duels. It designed them to end wars. The P-47 wasn't created for beauty. It was created for production, endurance, and overwhelming firepower. Its design came from a Georgian-born immigrant, Alexander Kartveli, who had fled both revolution and tyranny before finding refuge in American industry. When the U.S. Army Air Corps demanded a high-altitude interceptor in 1940, Kartveli ignored convention. He didn't try to match the German ideal, he set out to replace it. He told his engineers, "It will be a dinosaur, but a dinosaur with good proportions." And he was right. Beneath its ungainly form lay one of the most advanced engines ever built, the Pratt & Whitney R2800 Double Wasp, an 18-cylinder radial monster that could sustain full power at 27,000 feet, long after German engines had begun to suffocate. Germany's air doctrine depended on tactics. America's depended on logistics. One trained elite pilots. The other trained systems, factories, fuel lines, training schools, and spare parts moving in perfect synchrony. As Hermichen's squadron prepared to dive on those milk bottles, they were obeying the old laws of war. They were about to discover that those laws no longer applied. The age of the ace was ending. The age of the system had begun. The war they were fighting above France was already being decided thousands of miles away in the furnaces of Indiana, the assembly lines of Long Island, and the fuel depots stretching across the Atlantic. While German pilots sharpened their instincts, American engineers were sharpening production schedules. At Republic Aviation's factory in Farmingdale, Long Island, entire aircraft were being assembled in less than 24 hours. The Thunderbolt's engine, the Pratt & Whitney R2800, was the most complex single piece of machinery in the Allied arsenal, 2,400 precision components machined to microscopic tolerances. Yet, every hour, another one rolled off the line. To the Luftwaffe, war was a duel. To America, war was a supply chain. Every P-47 inches the sky represented not just a pilot, but a network of workers, railways, foundries, and refineries, operating in silent synchronization. Behind every mission was a logistics web so vast that no single mind could comprehend it. When Major Donald Blakesley, commanding officer of the 335th Fighter Squadron, took his Thunderbolts into combat that April morning, he was flying not as an individual, but as the living extension of an entire civilization's industrial will. He knew what his men didn't yet understand. Survival in the P-47 required abandoning everything they thought they knew about air combat. The Germans had built fighters to outturn, outclimb, and outdive their enemies. The Americans built one that could outlast them. In the coming months, that difference between speed and endurance, between skill and system, would rewrite the rules of aerial warfare. By summer 1943, reports from the front began to puzzle German intelligence officers. Thunderbolts that should have fallen from the sky were limping home with holes the size of fists in their fuselages. Engines shredded by cannon fire were still running. Pilots covered in hydraulic fluid were landing safely. What they were witnessing was something alien to their philosophy. A machine designed not for elegance, but for survival. The Luftwaffe's finest engineers had built perfection that could not be mass-produced. America's engineers built imperfection that could not be stopped. They laughed at its weight, but its weight was the reason it lived. They mocked its bulk, but its bulk was the armor of a new age. The contradiction had arrived not in the form of a better pilot, but in the form of a better system. The transformation of the P-47 Thunderbolt began not in the sky, but on the ground. In the hangars of the 56th Fighter Group, training fields from Bridgeport to Connecticut echoed with the roar of machines that pilots didn't yet understand. They called it the Jug, a name born half from affection, half from fear. At first, the Thunderbolt seemed suicidal. It killed more Americans in training than Germans in combat. It ground-looped on landing, torque-rolled on takeoff, and dove so fast that its control surfaces locked under compressibility, a phenomenon few pilots had ever experienced. Between September 1942 and January 1943, 18 pilots and 41 aircraft were lost before the 56th ever reached Europe. Major Hubert Zemke, who would later become one of America's top aces, called it bluntly, "You didn't fly it, you aimed it." But those who learned to control it discovered something astonishing. The Thunderbolt wasn't a fighter in the old sense. It was a flying fortress reduced to a single seat. It could take hits, dive like a comet, and deliver destruction on a scale never seen in aerial combat. The numbers were almost obscene. 8 50 caliber Browning machine guns, 3,400 rounds of ammunition, a combined rate of fire over 6,000 rounds per minute, enough to saw a Messerschmitt in half in 2 seconds. When those guns spoke, they didn't bark, they roared. It was the sound of American industry weaponized. Metal on metal, synchronized, relentless. German pilots began calling it Roosevelt's piano. Each note it played was made possible by factories thousands of miles away. Each bullet manufactured to within 10,000ths of an inch. Each cartridge identical, Each belt of ammunition assembled by hands that would never see the war they were fighting, and when those belts met the sky, they erased everything. When you hit them with all 8, recalled Lieutenant Francis Gaby Gabreski, they don't just go down, they explode. By mid-1943, Thunderbolts were climbing to 30,000 feet, where Luftwaffe engines gasped for air. The turbo-supercharged double Wasp engine kept its power, forcing German fighters to face an enemy that could dive faster than anything they'd ever seen. At 550 miles per hour in a vertical dive, the P-47 became unstoppable, a falling hammer of steel and gravity. The pilots called it boom and zoom. To the Germans below, it looked like the laws of physics had turned against them. The American philosophy was emerging in full view. Don't turn. Don't duel. Don't play their game. Strike once with everything and vanish. The Thunderbolt's strength wasn't elegance. It was momentum, mass, and firepower, an engineering expression of America itself. By late 1943, when the Luftwaffe still thought of the P-47 as slow and clumsy, the Allies had already changed the game. They didn't need aces. They had an assembly line of destruction. Each month, Republic Aviation produced more Thunderbolts than Germany could replace in pilots. Each week, new squadrons arrived, trained in tactics born from trial and attrition. Each day, the system grew stronger, learning, adapting, evolving. It wasn't a war of airplanes anymore. It was a war of factories, and the factory was winning. By the summer of 1943, the laughter had stopped. The Luftwaffe's radio channels, once filled with confident banter, were now filled with static, alarms, and the hollow sound of disbelief. The Germans had mocked the Thunderbolt for its weight. Now, they feared it for the same reason. The first cracks appeared over Lisieux, France, when a lone American pilot, Lieutenant Robert S. Johnson, faced 16 Focke-Wulf 190 seconds and survived the impossible. His aircraft returned to base leaking fuel, oil, and blood, with over 200 bullet holes in its frame. The canopy was shattered, the control cables severed, the engine coughing its last breath. And yet, it flew. One German pilot emptied his entire cannon belt into Johnson's P-47, circled in disbelief, saluted, and flew away. The Thunderbolt landed. The crew chief stopped counting bullet holes at 200. For the Luftwaffe, this moment was a revelation and a horror. Their mathematics of destruction had failed. They were facing a machine that didn't obey their equations. The reports filtered upward from squadron to command, from command to Berlin. The conclusion was unthinkable. No aircraft should survive what this one just did. But the impossible kept happening. By October 1943, aces like Hans Philipp, a veteran of more than 500 missions, were dying at altitudes where German engines could no longer breathe. At 28,000 feet, his Focke-Wulf 190 amperes 6 stalled mid-turn just as a flight of Thunderbolts dove from above, guns roaring. His aircraft disintegrated in mid-air. No parachute opened. The age of the individual hero was over. For every German ace lost, America trained a dozen new pilots. For every aircraft destroyed, a factory replaced it within days. The Luftwaffe was fighting a war of craftsmanship against a civilization of assembly lines. In November 1943, a report reached Reichsmarschall Hermann Göring. Its tone was clinical, but its implications were apocalyptic. The Thunderbolt's service ceiling exceeded 42,000 feet. Its dive speed approached the sound barrier. Its armor could absorb hits that would destroy 3 German fighters. Its firepower, concentrated through 8 synchronized machine guns, could erase anything within 6 feet of convergence. Göring read the final line twice. It is no longer possible to engage these aircraft on equal terms. He said nothing. The empire of aces had met its terminus. By early 1944, when new P-47 variants arrived with paddle blade propellers and external fuel tanks, the transformation was complete. What the Germans had once mocked as a flying joke had become the sound of extinction. On the radio, one pilot was heard murmuring before his final sortie, "When you hear the thunder, it's already too late." The Luftwaffe had not merely lost the sky, it had lost the logic of the world it understood. Courage had met industry, and courage lost. They had believed war belonged to men, to pilots who danced with death at the edge of the sky, to instincts honed by battle, to courage and precision. But the Americans believed something else. They believed war belonged to systems, to factories, blueprints, logistics networks, and the relentless repetition of production. The P-47 Thunderbolt was not just an airplane, it was the embodiment of an industrial civilization's mind. It was forged in steel, multiplied by mathematics, and sustained by organization. Every rivet in its frame, every round in its guns, every gallon of fuel it consumed was part of a synchronized logic, the logic of abundance. While German factories built perfection by hand, American factories built imperfection by the thousands. While Germany created heroes, America created momentum. In the end, the difference was philosophical. The Luftwaffe fought to preserve mastery. The United States fought to perfect efficiency. To the German pilot, every mission was a test of skill. To the American pilot, every mission was a process executed by a system that could not fail. This was the lesson the 20th century would learn again and again. The nation that controls production controls destiny. The factory became the true battlefield, and the engineer, its general. By 1945, when the smoke cleared, the sky no longer belonged to men with instincts, but to machines built by systems that could outthink, outproduce, and outlast them all. The P-47 Thunderbolt didn't just win battles. It redefined civilization's idea of power. War was no longer about courage. It was about a civilization's capacity to organize. May 1945. The war was ending, but the sound remained. Across the silent ruins of Europe, men could still hear it, that distant metallic thunder rolling across memory. The roar of the Pratt and Whitney R-2800, once the heartbeat of America's sky, now echoed like a mechanical requiem for an empire that had believed too deeply in flesh and instinct. In interrogation centers from Oberursel to Nuremberg, captured Luftwaffe officers were asked the same question. What destroyed the German Air Force? One of them, a weary ace who had flown since 1939, answered simply, "We laughed when we first saw them, those fat, clumsy American machines. We stopped laughing when we realized they didn't need to turn or climb. They just pointed their guns, and you ceased to exist." At the United States Air Force Museum in Dayton, Ohio, a single P-47 stands under the lights. Its aluminum skin reflects faintly dull silver, worn by time. Next to it, a strip of gun camera footage runs in an endless loop. A German fighter disintegrating in mid-air under a wall of lead. Beneath the display, a small plaque reads, "They were not defeated by weapons, but by a civilization that understood systems." The engine that once carried a pilot through fire now rests silent. But in that silence lies the echo, not of a single machine, but of an idea, that in the age of industry, power is no longer human. It is systemic. The sky fell quiet, and in that quiet, the machine had the last word.